Good afternoon.
Hello.
Okay, so I think we're done with all the reactions for test 2, and I've even been through and showed you what kind of possibilities you'd have for reactions as part of question 1. Let's go back through, a test here. I'll pick out spring 2020. Let's go ahead and share the screen too, huh? I think that might be useful. Okay. All right, so you all can hear me, correct?
Dr. Musgrave,
Yes.
could we do a test that you haven't had the key uploaded to?
Sure, but I actually wasn't going to start doing tests yet. Sylvia, I don't know, was it who asked me that? I'm sorry. Was it Sylvia?
Sorry, yeah, it was me.
Okay. Yeah, I haven't. When I go through and actually do a test, yes, I'll do that. But presently, I was going to go through and show you some things I hadn't shown you yet.
Okay, thank you.
So we've been through question 1, and I've told you what possibilities there are for question 1. Did anybody have any questions about that? If you don't know what I'm talking about, go back to the end of the Zoom session for Thursday's class, last Thursday's class, okay? All right. So question 2, as I had outlined earlier, is going to be something to do with primary or secondary amine addition elimination reactions. This one here happens to be a secondary. Note that in the mechanism problems, you're always given a reactant and a product. And then question 3 would be the cyclic acetal formation or water reaction or hydrolysis. Now question 4 is going to be a Proton Nmr problem where you'll be given a molecular formula and a spectrum. Now, one thing about this, let me get rid of some of this stuff here. Is that it'll be an aldehyde or a ketone. So just to remind you, let me get rid of that too. What I mean by that. So aldehydes have the formula of this, and ketones have the formula of this. So the thing with aldehydes is that they have a hydrogen attached to a C double bond O, and that hydrogen will be at around 9 to 10 ppm as a 1H. I guess it wouldn't have to be a single peak. It might be a multiple peak, but there will definitely be a 1H at around 9 to 10 ppm. With the ketones though, anything that's close to a C double bond O, so CH connected to a C double bond O, you'll usually see between 2 to 3 ppm. So let's say, well, I'm going to go through and I'm going to do this one here. Because you're told that it's an aldehyde or a ketone, I think you can be definitely assured this isn't an aldehyde because there's no 1H peak between 9 and 10 ppm. So we're kind of left with it being a ketone, which kind of really helps out here. So for something like this one, let's see what the formula is. C12H16O. Which means that it's going to be C12H16. And if it was saturated, it'd be C12H26. 26 minus 16 divided by 2 is 5. So 5 double bond equivalents, which points to there being an aromatic ring, which we can already see in the proton spectrum anyway. So looking at what we have here, we know that we've got C12H16O, and we've got a 5H, that's your aromatic ring, so I'll just make that C6H5. And that's going to cover 4 double bond equivalents. And that's 5 double bond equivalents total. So we know we're going to have 1 left over most likely. So we've got C6H5, we've got the CH2 there. And we've got a 6H, because it's a single peak, likely to be 2 CH3s. And then another CH3 as well. And then that would mean we've got 6, 10, 12. We've got 2 Cs left and an oxygen and a double bond equivalent. So we've got a C and a C double bond O left over. And then we can try and put something together here. And that would be, let's see, so let's pull this down a bit so we can still see the spectrum. Okay. All right, so we know it's got C double bond O. My point was that anything in the 2 to 3 range is likely to be something connected to a C double bond O. So I could automatically go ahead and put the CH2 that's here as part of that. So we've already taken account of the CH2, and then that CH2, because it's got 4 peaks, must be next to a CH3, which must be this CH3 over here because that's got 3 peaks, so it must be next to a CH2. So what's left over here is a C6H5, 2 CH3s, and an aromatic ring, and there's only one way you can put that together. And that would be like this. So that would be the final answer there. So it's actually immensely helpful on this test knowing that you can only have an aldehyde or a ketone. And if it's not an aldehyde, then putting the ketone together is not incredibly difficult. When you consider that anything between 2 and 3 is what's connected to the C double bond O, then you can work your way out from there. Does anybody have any questions about number 4? Okay. Now, let me make sure that you understand this as well. So if we go back and look at the Proton Nmr exercises and answers folder, there's an index of functional groups and exercise. Here we go. So if you wanted to see some examples of aldehydes and ketones, here they all are here. 40, 41, 55, 58, those are aldehydes, and then these other ones down here, these are ketones. So if you wanted to just practice aldehydes and ketones, this would be where you might go to find that. Excuse me. Does anybody have any questions? All right.
What are those numbers?
When you go to this NMR tool, which the link to that is also in the folder. It's these numbers here, Miriam.
Oh, I see. Okay. Thank you.
All right. Anybody got any other questions? Okay. So that's question 4. Now question 5 is going to be a synthesis problem. I'm going to go through that now in a second. That's the next thing I want to look at. And then finally here we have a roadmap problem, and I wanted to go through some of those as well. Make sure everybody understands what they need to do with that. So you all understand that the test is next Tuesday, right? Everybody's clear on this? All right, nobody's saying anything, so I'm assuming that everybody's okay with it. Okay. And that's it for the test. So let me go through number 5 here. Now, because there's not that many reactions on the test, you guys can sort of take a bit of advantage of me here, because my questions, or the questions I could ask, are really very limited for the kind of synthesis problems that I can come up with. So the reality of the situation for me, and it's very sad, is that I am limited to these kinds of problems. I can do something that starts with a ketone, say C double bond O. I can treat it with a Grignard reagent, which would give some kind of alcohol. And then that could be oxidized. And remember that O in the square brackets just means oxidized. To something with the C double bond O. So I can do that. That's an option. Let's see, what's the other one? Taking an alcohol. Yeah. And oxidizing it to our C double bond O, and then treating that with some sort of Grignard reagent. And yeah, that's pretty much it, which brings in another alcohol here. So it's kind of very sad for me, but because I'm so limited in the kinds of questions I can ask you. Are you guys sad?
Terrible.
Definitely not.
All right. So take a look at the question that we see here. What do you all think? Which one do you think that falls into? The
Second
first or the second one? Probably the second
The
one,
second
right?
one.
Because it starts with an alcohol and ends with an alcohol, right? Kind of takes the legs right out from under me, doesn't it? All right, so that's the kind of thing that you'll see. So let's go through this one here. I'm going to go through a bunch of them on these old tests, and we'll see where we end up. All right, so the story will always be with these that you can solve them in 2 steps. And your mission here is to figure out A, B, and C. So what's on the arrows here? Okay. So now we have to figure out, well, what's going on here? Well, the thing is that since this test is about aldehydes and ketones, then, you know, you can be pretty sure that B would have to be an aldehyde or a ketone, because if it wasn't, then, you know, I don't know what else it could be, since these are both alcohols. So I would expect that to be an aldehyde or a ketone. And I think you can be pretty sure then that in order to have come up with this alcohol, that it would have had to have been the result of addition of a Grignard reagent to a C double bond O. And we know this because this compound that we have at the end has more carbons in it than what we started with. So we know that a Grignard reagent is somewhere along the way. So I think what I'd be inclined to do first is, rather than work backwards, it would be easier, I think, to work a little bit forwards here, knowing that this first step here was an oxidation. And I could do PCC, and that would give me this ketone. Now I have to figure out, well, what would I have to add to this ketone in order to come up with the compound that I have at the end here. So that's the question I'm facing right now is, or, you know, what goes on this arrow here? Well, I know it's a Grignard reaction, because that's how I can go from a C double bond O to an OH and add carbon atoms. But what I have to do here is see, well, what am I adding? What was here originally? And if you look at it, I'm going to put a sort of a circle around this part. And I want to determine where that was in the product, and it's here. Does anybody have any questions? So you can see the part that was added here, and I'm going to put that in like a square or something, is this part. I haven't really done a good job of that. Yeah, it's a little bit better. Okay, so the part in the square or the rectangle I've drawn here is this part here. It's got the two carbons on it. Now, if you were to look at how a Grignard reagent reacts, it goes like something like this. I'm just doing something very general here. But the point is that you can see that this R prime prime group, which was the Grignard reagent, comes from a Grignard reagent, is added to the C that has now an OH on it. If I wanted to do a mechanism, this is what the mechanism would look like, and you can see how this relates. And then the H plus gets added, and that's how we end up with our product. Does anybody have any questions? So you might be wondering, well, what's that got to do with anything? Well, if I'm telling you that the group in the rectangle is the one that got added, then that's what's connected into the Grignard reagent. So the Grignard reagent must be this. And then we'll have 2H plus here as a second step. Does anybody have any questions? Okay. Now I do have some more examples of these kinds of things in the blue book as well. Let me point those out to you. Problems test 2, download. Let's see if I can find it. I think it's after these. Here we go, synthesis problems. So these are some synthesis problems. Some of them are similar to the ones that we're looking at here, but they're good practice just for synthesis in general, I think. Those have answers on them as well. All right, let's look at another example from another test here. And that one's pretty similar to the one we just did. So I won't do that one. Looking for one that doesn't start with an alcohol. There we go. This one starts with a Grignard reagent. It's probably a good one to do. So it's not exactly the same form as what I was showing you, but it's related to it. Now, if you remember what I had said when we were doing Grignard reagents, is that the Grignard reagent and whatever's in front of the arrow are interchangeable. So in this instance, it's the Grignard reagent that's kind of out the front here. You can see it there. Let me move this down a little bit. There we go. So the situation is this situation where the Grignard reagent is in the front, and it must be an aldehyde or a ketone that's on the arrow. But if you look at how it goes, focus on this last step here. If it's got a C double bond O as the product, and the only way we can get that C double bond O is to have done an oxidation. So I think when you're finishing with a ketone in these kinds of examples, you're probably well advised to work it backwards. And to figure out what sort of goes in the middle. Actually, I'm going to just remove the bottom part here. Okay. Let's see. Sure, I can just run here. So my point here is that I know that in order to get to that last thing, what would have had to have happened is that probably PCC here is this alcohol group. And now I have to figure out, well, what goes on this arrow here to take me from the starting material through to the end. So given that that's the Grignard reagent, which is R primed here, which I'm going to put a circle around, then I can find that specific shape somewhere in this second compound here, which is going to be here, which allows me to now figure out, well, what would this have been added to? Well, it has to be an aldehyde or a ketone, but remember, I'm switching these two things around. They are interchangeable. So I have to figure out what C double bond O compound would have gone here, and what it is, the C double bond O compound that does go there, which I'll draw down here, is going to be this one. All right, so that's the aldehyde that would go there. Does anybody have any questions? Okay, I'm going to put in a poll here in a second. Well, let me throw this poll here. Okay. So I'd really like an indication of where people are at the present time.
I have a question about the last one.
Yeah.
Well, when you circled that, what the Grignard reagent was,
Yeah.
it included like a line. You know how usually you have to connect it to something?
Yeah.
So where is it? Let me see. Okay, so you circled it. You can't see where I'm pointing to, but on the right side screen, you
Yes.
circled the Grignard reagent.
Right.
So technically, that should have another line that's going to attach it.
No, the C that's
See.
attached to the Mg is what's going to attach to the C double bond O. I mean, if you look at the thing here. All right. So I can see that about maybe a third of the class gets it now, and it's still a third halfway understand it. Okay, that's all right. Julie,
Yes.
did I answer your question or not?
Well, I'm not sure how I would, for some reason, it always seems like there's an extra line that connects it, an extra bond that connects the Grignard reagent.
Well, that it would be the extra bond right there that I'm pointing to with the cursor, where the line goes through.
Draw on the, oh, okay, because it's connected to the, okay, I do get it, because it's
All right.
connected to the BRMG.
Okay. Okay.
Thank you.
All right, let's go. We'll go back. We'll do spring 2019. I'll do this as an example. Now this is similar to the first one we did. Okay. So I'll go through this one. Let me move this over a bit. Okay, that makes it a little bit easier, I think. Okay. Okay. So we're starting out with an alcohol. And we're ending up with an alcohol. So what I had said is that we know the first step is going to be an oxidation. So this is how I would definitely start it. And I would use PCC. Use PCC all the time as your oxidizer, and you'll always get what you're looking for. So all we're doing there is taking that OH, turning it into a C double bond O, and then we need to get whatever we can get here in order to get what we need as a product. All right. So now I've got PCC in the first step. Is everybody okay with that? Does anybody have any questions about why I'm doing what I'm doing in the first step? So I know I need a Grignard reagent in the second step. I guess I shouldn't have deleted that other thing, but it doesn't really matter. So what I've got to do is find out where this is in the product. And this whole thing comes from here. So it's the whole left side, sorry, right side of that product. So now I have to figure out what Grignard reagent would be added, and it's going to be the rest of it, which I'm going to put another shape around here. And that would be that Grignard reagent. Yeah, I wish I hadn't have deleted that other thing. So I'll put up that Grignard pattern again.
That sets me back to the same question.
Well, it's the reverse situation, isn't it, Julie? We're now looking at the Grignard reagent that we need, not the aldehyde or ketone that we need to add to it.
Right, but the aldehyde, I mean, the alcohol had ended at the OH, just like the
Yeah,
just like aldehyde.
but don't forget that C. This is the arrow I'm pointing to here. The C that's got the C double bond O is the C that ends up being the C with the OH on it.
Right. So there's still another line there.
Hang on, let me see if I've got, you know what, I think I might have made an error here because I have to look at the thing. You're right, there should be another line there, you're right. I'm sorry, Julie.
Okay.
This one, you're right. I didn't see it. I didn't see that because I had squeezed that in so much.
Okay.
I'd actually missed that other line there. I didn't mean to squeeze it in like that. But anyway, yeah, it's like that. So looking at the, do you see where my cursor is, Julie? Do you see where my cursor is here?
Yes.
Do you see how it's cutting that line? So everything on that side of the line is going to be the Grignard reagent.
Okay. Yeah.
I think you had gotten that. Yeah.
Yeah.
Okay. Does anybody have any other questions about this? Yeah, I could have handled that a little bit better here. All right. Any questions?
And if we do it exactly like that on the test, we won't lose any points. Just show where the
Yes.
arrow.
Yes.
Oh, okay,
Yeah,
cool.
yeah. You don't have to show any mechanisms or anything. You just have to show what the thingies are. You know, the things we're adding, and the middle thing, of course.
Thank you.
All right. Let's have a look at the spring 2017 one. Yeah, it's very limited what I can ask. Oh, here's another one. It's got an alcohol on it. Why don't you all try that one? Why don't you all try it?
Could you don't erase that one just yet? So the second, how did you find? I mean, I can see where the C is bonded to OH.
Let me expand this out a bit, Miriam. This is the same diagram. I'm just drawing it bigger, okay?
Oh, yeah.
Hang on. No, let me make it more consistent. It's not wrong. It's just would have looked weird. Let me try this and make sure it's consistent. I want to kind of blow it up a bit. So let me. So it looks like that, Miriam.
Okay.
And the first group I circled was this one because it matches the aldehyde here. Do you see?
Okay. Yes.
The rest of it is what goes on the Grignard reagent.
Okay.
That was the argument I was just having with Julie, because I hadn't realized that there was an extra C in here because I squeezed it in too much. Are you okay, Miriam?
Yeah. Yeah, I understood it. Thank you.
Okay. Anybody got any other questions? Okay. Well, let's look at this one then. See if you can come up with an answer to that. I'll give you a hint. On the first one, you'll be treating it with PCC to get an aldehyde, and then you've got to figure out what Grignard reagent you'd react with that aldehyde. So it's pretty similar to what we just did. See, the first step here is oxidation. So just PCC, turn the OH into a C double bond O. That's what you should be doing first. In fact, I'll do that part. Spoiler alert, I know. But
Dr. Musgrave, can you do one that's not PCC so we have an idea? Or is it always going to be?
you can always do PCC.
Okay.
But the thing is, PCC is good for secondary or primary alcohols, but you can only use CrO3 with secondary alcohols. So why not just use PCC all the time?
Okay.
I think it's good advice. If you want to do CrO3, it's not a problem, but you have to do it on secondary alcohols only. So what I'm trying to get you to do here is figure out what Grignard reagent needs to be added here. Does anybody need more time? Okay. So what I do is I'll circle the area that the aldehyde is, and then the rest of it's going to be the Grignard reagent. And the Grignard reagent will look like this. All right, does anybody have any questions? Okay. Let's take a look at the next one then. See if I have something here. It's a little bit different. Okay, yeah, it's a good one to do. Sorry. All right. So you see, this is the top case, right? And we've got to figure out what goes in the middle here. So when you're finishing with the C double bond O, what I had suggested was that you take it backwards to the alcohol that it was before. Because we don't have a reaction that forms a C double bond O except for that. Okay, so now we have to figure out what Grignard reagent goes here. And what you would do is, again, just find out where the aldehyde went. You can see it went here. It could have gone on either side, actually. It's symmetric. And this ends up being the Grignard reagent here, which would look like this. All right, does anybody have any questions?
No.
All right, I'll let you have a go at this one. See what it comes out as. I don't know. Can't remember which one it is. Yeah, I like this one. All right. So why don't you all have a go at this one? As you can see, I like to kind of flip shapes around and things to sort of, I know it kind of makes it a little bit more confusing, but that's the whole point. That's what I'm trying to do. Make it so that you really have to think about what gets added. You're not really able to just wing it. All right, so have a go at that. Oops. But you can see I am limited to just those really two examples, essentially. All right. Anybody want more time? Okay. So PCC. And then the alcohol here turns into the ketone. Oh, yes, yeah, secondary alcohol turns into a ketone. I could have used CrO3 here if I'd wanted to, but PCC is fine. So now I have to figure out, well, where did this end up? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. See, it's flipped upside down. Makes it look a little bit different. But that's the group there, which makes the Grignard reagent this one. All right, does anybody have any questions? Well, let me do the poll again. We'll see if we got any improvement. So I've put up another poll here. Give you another 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So yeah, a whole bunch more people understand this. Anybody who still needs help with it can contact me. And you know, maybe, okay, well, yeah, I think we'll just leave it at that. We can do more of this on Thursday too, if anybody's still concerned about it. We can do another couple of examples. I can come up with some on my own if anybody's concerned about it. Okay. Let's focus now on roadmap problems. Now, if you've taken me for organic 1, then you would already be aware of how these go. Okay, roadmap problem. What we're looking to do is figure out, it could be either compounds or reagents. If it's compounds, then it's things between arrows. If it's reagents, then we're talking about things on top of arrows, and it could go either way as to what you might be looking for here. So when you're solving a roadmap, there's 2 ways generally you can do it. You can start at the beginning and work your way through to the end, which can work if you are aware of the reactions you're doing, but sometimes it's useful to be able to work backwards as well. So if you were to, let's say, look at this one here, and you might wonder, well, how might I get A? Well, what you can do is, you don't have to show this, but you can do a mechanism. And you can probably come up with A this way. And this would be what A would look like. You'll notice I didn't put the hydrogens on here, but I don't have to. Does anybody have any questions about getting A that way? All right, then I could get PCC, and that would turn this into an aldehyde, specifically this aldehyde. Any questions? This would be B. And we can also use some clues here. When you've got a Grignard reagent here on the arrow between B and C, that should tell you that B is probably an aldehyde or a ketone, because we haven't really talked about very many reactions that involve Grignard reagents, and really I think it's only aldehydes and ketones that we talked about. So that's another clue that B is an aldehyde or a ketone. So I still like to sort of use mechanisms here to help me through. So if I was looking for C, this would be the Grignard reagent. And that would be, well, then I have to add H plus to it. And that would be C. Then I could hit that with CrO3, and that would be D, which would be an aldehyde or a ketone, when it should match what's going on down the bottom there as well. And it looks like it does. So that would be, well, that would be D. Does anybody have any questions? Now, I told you that this could be worked forward and backwards. So if you were looking at D and you weren't really sure, let's say you didn't know these reactions to get to D, you should be able to figure out what D is based on what you're seeing here. If you know what kinds of compounds we're going to end up with here. So the reaction with a typical, NH2OH that we talked about before, so if you knew that NH2OH, NH plus would start from this C double bond O compound, then you could work that backwards and come up with D that way. And that would be D as well, if you knew that reaction. Now, how might you know that reaction? Well, possibly you might, if you get lucky, and it's not always the case, you might see it as part of question 1. I don't know if we did though. It's not looking good. No. Okay. Sometimes you can get lucky and you can see the reaction in question 1, and that might help you out too. Does anybody have any questions about that roadmap problem? So yeah, there's a number of ways that you can do this one as well. But looking at something like this, you might be a little bit confused by it initially, but you've got this Mg here. So you should be able to work this backwards and figure out what D was. In order to make this Grignard reagent, you would use the previous compound there. This would be D. Would look like this. because that's all the magnesium does, is puts an Mg between the C and the Br. Actually, I think I might have skipped out on a C there, didn't I? Let's try that. That's more like it. Yeah, so the Mg goes in between the C and the Br. And if you knew what would form this compound here, knowing that we had question 2 there, so this would be C, you could work this backwards, and C would be this, be the ketone with the bromine attached to it. Then B would be that compound there. That would be B. So you could work, this what I'm trying to show you is that you can work your way backwards through the reagents if you can't work your way forwards. Does anybody have any questions? All right, I'll finish up A and E there as well. So let's say you had wanted to get A. Well, you could just say, well, CrO3, this would be an alcohol, and that alcohol would look like this. So this would be A. This is kind of what I did earlier with that reverse. If I know that I have a C double bond O as a product, then the OH is what was the predecessor to it. Does anybody have any questions? Okay, and then the last one here, E. And again, I think mechanisms kind of come in handy here as well. Which is why I've pushed the mechanism so hard in this test. And that would be E. Does anybody have any questions? Okay. So that gives you an idea of how to deal with them. I can't guarantee that the reactions from the roadmap will be in question 1. Sometimes they will be, sometimes they won't be. But you can sometimes get some help from question 1 with the roadmap. All right, let me remind you how you should be reviewing for this test, and I'm hoping that you've already started. So just reacquainting you with the things that I think you should be doing. Hopefully you've already done the naming quiz. If you haven't done that, you should be doing it right now so that you're not left with trying to do that while you're trying to study for the other parts of a test, and a lot of people do that. I have these reaction summaries here which go through and give you mechanisms for each kind of reaction. So that's something you can reference. You've also got the PowerPoints for that as well. but they're very general reactions that you're looking at here. Then, of course, you've got these mixed problems, and there's 54 of them, I think. And I would recommend that you, well, they do have the answers here, but the mechanisms are in a separate file, this mechanisms test 2 file here. I don't recommend that you print them out. Some people do, but you don't have to. But all the mechanisms for all of these problems are in that mechanism file. So I'd recommend that you check your mechanisms against the ones in that file after you've done that. I think that is by far the best way to study for this test. Now, there's going to be a lot of people who disagree with me. They're going to say, well, no, I think I can just memorize the products. I think I'll be good, Dr. Musgrave. I don't think I need to learn your stupid mechanisms. That's okay. You can say that. But I think you should learn my stupid mechanisms, because they'll be helpful to you in the long run. It's very much a shortcut that will probably end in a lower grade than you would have gotten had you actually gone through and done the mechanisms. All right, does anybody have any questions?
I have a question about what you added this morning.
What I added this morning?
Something about nomenclature.
I'm a little bit lost here, Julie.
Something went on today about, came out about nomenclature, and I was just wondering what test it was for, if any.
I don't remember adding anything this morning.
Maybe
I think that was like tutoring center. It'll sometimes notify you.
Oh, okay. All right. Yeah, it wasn't me, Julie.
Okay.
I promise. I didn't do it.
I watched the video.
Oh, okay, good.
It hurt.
I don't know if it was useful to you or not.
Not in these tests, but.
Yeah. Anyway, I'm hoping that people have, well, a number of people hopefully have done. I haven't looked to see who's done it and who hasn't yet. But you should have done the naming quiz by now. And if you haven't done it, you should get to do it tonight, I would say. So you're not left doing it at the last minute and trying to decide if you want to study or do the naming quiz. It gets all very stressful at that point. All right, any other questions? Okay, on Thursday, I will go through a test. Right, I will go through a test. One of the ones that doesn't have keys on it, but I'm still looking for keys for some of those for those 2 early tests there. If somebody could get them done and then send them to me, I'll post them. And you know, somebody did send me a key for the last one, but it was like the day after the test, so it wasn't as useful to people as it might have been. I'm not sure if everybody's just waiting for everybody else to do it. I don't know. That's probably how it's going down.
No, you have to actually get it right for it to be.
Well, yeah, but I'll look at it. I'll grade it.
Yeah, but it's not going to be the key if they're all wrong.
True.
So you wait until you can get it right.
Well, look, I don't know, Julie. Well, that's all I'm saying. But I'll go through one of those tests on Thursday. Okay. If I have time, I'll go through a second one too. We'll see. We might. All right. Any other questions? Anything general about the test? Anybody needs to know? All right. I think we'll leave it there for today, and I will see you all on Thursday.
Thank you.
Okay. Thanks.
Thank you, Dr. Musgrave.
No worries. Bye-bye.
You.